continuing my little coding stuff. If anybody has any information or cares to join, I'll be chilling.
In the last
Coffee
lecture,
kicking in.
we added looping variants. We had for loops, we had while loops, we had the notion of iteration. We used that to start generating some examples of guess and check algorithms. In this lecture, we're going to go back to that idea, but extend it, and we're going to add in another kind of data type, a string. We talked about it a little bit earlier on, but we're going to use it to actually look at ways to generate algorithms that can start to do some more interesting kinds of things. Just to review, I want to remind you what we did inside of loops. Here's an example of some code that's going to compute a square root of something.
A square root of something. Flag equals false. Integer input into the integer. If x is less than 0, negative flag equals true. Well, answer is square root is less than x. Hey, what's up? I just started trying to learn all this coding stuff. It's so much work. It's not easy. It's not easy. It was easy in the beginning. Now it's starting to get a little difficult, but equals x. Hey Milton, were you on me last time I was doing the coding stuff? Oh, I'm trying to remember it. I don't know. I got a bad memory. I don't know if you were one of the, your name looks familiar, but I can't remember which one you were from.
And it does it by running through a loop. As we've done before, it's going to set up an initial value, which it gets here by inputting something that enters an integer. And then it's going to run through a little while loop where it does guess and check. It keeps trying different versions of answers, starting at 0, then 1, then 2, going on until it sees whether that answer squared is bigger than or equal to x. Once it gets to that point, it checks to see if it's actually the square is equal to x, in which case it prints out that it's found the cube root. And if not, it tells me that it's not a perfect cube. And just depending on whether it was a positive or negative thing, it gives me a little bit of additional information. You can look through the code.
Oh, when I was playing Fortnite. Oh, yeah. Weren't you trying to play with me? And then it, like, somehow, I can't remember what was going on. But yeah, I remember that. That was like, what was that last week? What was it last week? I don't remember. It's been a minute since we were able to get on Fortnite, because we didn't play it this weekend. It was like last week, or I think it was last weekend. I don't remember. I remember that day though. Yeah. We haven't been able to get on Fortnite in a little minute though. I try to hop on it when I can, but
I'm not going to run it. What I want you to see is that idea of guess and check. I generate values.
I've been doing this stuff because I'm trying to learn coding, so maybe I could potentially get into the coding field. That'd be cool. I like it. So gotta try to learn something, I guess. Try to be productive.
For answer until I get to a point where either I'm done and I have the answer or I've gone too far. And again, as before, I've got something where I'm setting up the variable outside and I'm changing the variable inside with a test that depends on it. We're going to use that idea as we generalize, but I want to remind you of what loops do. And as before, I don't need to do that actual version of answer equal answer plus 1. I could use plus equal as a variation of it. We also talked about strings earlier, and I just want to remind you, though.
Oh shoot, I don't know. I'm just trying to learn coding right now. I mean, it'd be cool to like be able to make a game or something, but I don't even know how far down the road or how difficult that is. I'm just at least trying to figure the coding out first, and then see what I can do with it. Whether I get into gaming or anything that has to do with coding. There's just so many things you can do with it. This is the hardest part is just learning how it all works. So got to start somewhere. I mean, I still haven't seen how, like, I know coding works in the back end, but I still haven't seen how it works, like, when you actually put it into something. Like, I've seen, like, it work with, like, Python and stuff, but when they're, like, pulling Python, uh, putting that code into something to make it an actual usable thing, that's the only part I haven't seen.
Because we're going to use them in this lecture as well. Think of strings as a sequence of characters. In fact, case-sensitive characters. For letters, could be lowercase or uppercase. As with numbers, I can compare them. I can say if two strings are equal by using the double equal sign. I can use greater than or less than, using lexicographic order to decide if two strings are greater than or less than each other. Length can give me the number of things in the string. And as we saw before, we can use square brackets to do indexing into a string. We can get the 0th element. Remember, it starts at 0. The first element, the second element. And if I have a string 3 long and I try and get something 3 or bigger, it's going to complain, telling me that I've tried to access beyond the end of the string. We also saw slicing in strings. This lets us go into a string and pull out pieces of the string. And here we saw we can specify a start point, a stop point, and how many steps to take as we do the accessing. And that lets us pull out different elements out of the string. One unusual thing we haven't seen before is if the step is -1, we actually access the string in reverse order. There it is right there.
Yeah, I already figured it out.
Otherwise, if we say, for example, start with the element 3, it says 0, 0, 1, 2, 3. So I start here, and I stop just before the 6th one. So 3, 4, 5. I'm going to pull that out, which gives me the piece that I wanted there.
Well, it says 0 right now. I think I had 2 and then 1, and well, right now it's showing 0, so I don't know. It's all good. I'll just figure if I'm studying, I might as well stream it. Maybe it'll spark some other people to get into it, or if anybody knows how to get into it for real, then they can help me out or something. Might as well since I'm on my computer.
One last thing about strings is that they are what we call an immutable type. You can't change them. They can't be modified. And to see that, let me do a little example. I've shown it on the slide, but let me actually type it in over here. I'm going to define the string S to be, I'm going to define the name S to be the string hello. If I print out S, it gives me back. If I say what's the type of S, it tells me that it's a string, which is great. I can certainly index it by saying, give me the 0th element of S. But if I wanted to change the 0th element of S, for example, saying, I want to have the 0th element of S be the character Y, it's going to complain. I can't go in and change a piece of S. We're going to see other structures where we can do that are called mutable. Strings are not. I can't say, I want the 0th element of S to be Y. I can change it, but I have to redefine S. So I could say, let S be the character Y plus the rest of S starting at 1. And I could, in fact, say until I get to the length of S, or I can just say 1 all the way on to the end. And now, if I look at S, it's yellow. Misspelled for yellow. Point is,
That's
I've
weird.
now changed the definition for S. So I can't change it individually, I have to redefine S. And that's why I say strings are immutable. One of the things I would suggest to you is if you're not sure what a command does, look it up or try it out yourself. That'll give you a sense of the different things you can do with strings as you move along. And here, just to remind you, S was initially bound to hello. When I do the last call, I'm changing that binding and redefining it to be a changed new version of a string. The original string is still stuck in memory. It's just floating around. I can't access it anymore. Finally, remember for loops, the quick recap, we have that idea of having a loop variable that iterates over a set of values. And we can either do that with simple things like the range shown here, which is going to go from 0 up to 4, but I could also do it starting at 4, going up to 8. Expressions inside the loop are going to be executed for each value of the variable that I use. And so range is a nice way to iterate over numbers, but a for loop variable can iterate over any set of values, not just numbers. And so, for example, I could loop over strings. That sounds kind of neat. So here's a simple little piece of code. I've defined S to be a string, the first set of letters in the alphabet. And I can now write a for loop that says loop for the index over the range of the length of S. Boy, that's a lot of words. Let's say it a little bit better. It says, I'm going to see how long is S, and then I'm going to use range to generate the integers from 0 up to S, the length of S minus 1. I'm going to call that index, and then I could run through a loop that says if the element of S at that point is either an I or a U, I'm going to print out a little piece of information. No big deal. That just looks like a normal loop over integers. But I could also write it this way. I could say loop for character in S. And that's kind of cool. S is something we call an iterable. It says I can actually write a loop that lets characters start with the first element of S, and then the second element of S, and then the third element of S, doing the same kind of test as I move along. And it will do this until it runs out of characters in S, in which case it will execute, or exit from the loop rather, and move on to other kinds of things. That second piece of code is much cleaner. It's easier to see what I'm doing. I'm looping for all the characters in a string, as opposed to saying I'm looping for an index over all the indices. And that's
all
one
the
of the nice
emojis.
things about both strings and especially about loops.
Yeah, I don't know.
Iterate over anything
I'd stream something
that
more
I
interesting, but actually I gotta start learning this stuff. So
that piece. And now I've got
this is
strings
where I'm at.
I can use as parts of
Real
it.
life
And
stuff.
that's really nice. Let me give you one last example, sort of a fun example. I'm going to set up a little loop that is going to run over basically a set of words. And what is it going to do inside of here? I got a little while loop here that says, as long as, rephrase it. I'm going to input a word based on some input I give there. And what it's going to do is it's going to loop over all of the things inside of the word, basically saying if the character in the word is in a special set of characters, I'm going to print out something based on that. If it's not, I'm going to print out something different based on that. And then I'm going to increment I, and I'm going to keep going. So again, it's a while loop, but I'm using the character inside there to loop over particular elements of a string. Let's see what this does. So here's the code, and if I load it into my environment, it says I'm going to cheer for you. Give me a word. So we'll give it the best word I know, which is, let me just get it over here, which is MIT. And it says, how enthusiastic are you about MIT? Well, I like MIT a lot, so I'm going to give it a 10 out of 10. And it says, I'm not going to repeat it all, but give me an M. M, give me an I, give me a T. T, what does it spell? And it prints it all out. All right, it's a lame example, but you know what? I'm from MIT, I like it. What I want you to see is how I'm looping over, especially here, in this place right in here, I'm using the loop over a set of strings in order to be able to decide what I'm going to do. And why am I doing that? Because if it's something that is a vowel, I don't want to say give me a A, I want to say give me an A. If it's something like an M that we pronounce that way, I want to say give me an M. Whereas in the other cases, I want to say just give me a C, give me a D. Okay, cute example, key point. I've now got two different loops going on here. The outer one is walking through each of the elements of the word. That's this one right here. And that's just doing the standard thing where I've set an iteration variable outside, right there. I'm changing it inside the loop. But in the loop, I've got another one, which is right here where I'm looping over all of the elements of a string. I can do it either way, and that works out really well. On that cheery note, we're going to move on to another topic.
Well, this is an interesting little code he made for that. Jesus. Oh, God, here the exercises go. Okay. Alright. Iteration equals 0, count equals 0, while iteration is less than 5. The variable stands for every character, including spaces and commas. Okay, for letter in hello world. Okay. For a letter in hello world, count plus or equal to 1. Print iteration plus string iteration. Oh, so it's going to run it 5 times. But what would the string of iterate? The string wouldn't be. That iteration wouldn't be a string though, right? For a letter in hello world. Oh, iteration plus 1. Oh, I didn't see that on the bottom. I wasn't getting there. Okay. So, and this is in front of while, so this is going to happen as many times as this happens, and this is going to happen as many times as the while happens. And this is a string, this is a string, but these are going to be integers, so it's going to turn integers into strings. So it's going to say, let's see, I think it's like when you turn a s equals 5. Okay, and then print not integer, string s 5. Yeah, so and then s plus 2. So it says print string, but it still comes out 5. But is that a string? Okay, hold on. Does it really turn it into a string though? There it is. So it turns it into a string like that. It's still 5, but it's no longer a number. It's a type s, which I think I've already done this. Yeah, so yeah, it says integer now. But if you do s plus 2 equals 7, does that mean it turns it back into an integer? It does. Okay, well that's. Oh no, wait. String s puts 5, but it was still an integer. What? S is 5. String. Oh, when you put string s, it just prints it out a string, but it doesn't change the what type it is. That's. I am coming AFK. I'm back. I appreciate it. This stuff. It works your brain. Okay. What is the value of the variable count that is printed out at the print statement on iteration 0? So if the iteration is 0, what is the value of count? For letter in hello, counts plus equal to 1. So for every letter in here, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It should be 12. I believe that's how that would work. Because it counts all the characters. It should run this function separately first, because this is the loop right here. And this is a loop back here. So it has to finish this out before it gets to here. And then when it gets to here, then it has to finish out these functions to get to while. Yeah. I believe. No, wait. I think. See, I'm pretty sure this function has to go all the way through. So this has to hit 12. But then while iteration is less than 5, it has to redo this whole thing. So it's going to print this 5 times. But doesn't that also mean that this is going to go 12 times 5 and end up at, like, count's going to be at 60? I believe so. I'm not positive on this. But these are also, this is on the same line as this. But this loop, I think it stops here. So, ugh. Okay, I'm going to try 12. What is the value of the variable count that is printed out at the print statement of iteration 1? I believe it's, wait, oh, iteration 1, okay, I believe it's 24. And then iteration 2, as iteration 0 would be 12, 24, 36. Oh my god, it's going to ask this every time. 48, 60. Alright. And then iteration equals 0. While iteration is less than 5, count equals 0. For letter in hello world, count plus equals to 1. Print iteration. Okay. Wait a second. Now they moved count equals 0 to the while iteration. So every time we repeat this function of while, the count's going to return back to 0. So it will count up to 12, but then once this loops back and iteration goes from 0 to 1, 0 to 2, 0 to 3, count is going to return to 0, count back to 12. And so this is going to remain 12, and this is going to keep counting up. Okay, what is the value of count that's printed as 12? 12, 12, 12, 12, 12. Okay, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12. Okay, I should have that number right. Alright, next part. Iteration equals 0, while iteration is less than 5, count equals 0. For a letter in hello world, count plus equal to 1. For iteration 2%, I hate these 2% things. Okay, if iteration is 2%, or equal to a even number, basically, break. Print iteration, iteration plus 1. Okay, so the count is going to restart in any loop. But this changes things because this breaks the loop if iteration is 2% or equal to 0, break. So it's going to break on the first one. And then it's going to print. And then iteration is going to get plus 1. Plus 1 at 1. Yeah, when iteration's at 1 and this finishes, this is going to be at 24. Because it doesn't break. It breaks at 0, and then it's going to break at 2. Which means it's not going to loop. Wait a second. If iteration is already 0, oh, but you put the plus 1. But it's while iteration is less than 5, so it has to loop. But no, but it breaks. It breaks the loop because it's at 0. The loop breaks. before it has a chance to loop back. Oh, crap. Because this is the first, it's already at 0. That's already an even number. That's already, so it's going to break right here. That's it. Once it breaks, that's it. There's no loop back anymore. Okay, how many times will the print statement be executed? I believe once. What is the largest value of the variable iteration that will be printed out at the end of the print statement? 1. What is the largest variable counts will be at? 12. What is the smallest value of the variable counts that will be printed out of the print statement? I believe 12. Oh no, I got it wrong. I got these ones right. I got these ones right. I got the last one wrong. Okay, so I'm gonna have to see how this looks. Oh, I did something wrong. Alright, what are you gonna do? Okay, so it is able to loop even if it breaks. But it's gonna do what I initially thought. So it's gonna keep looping while iteration is lower than 5. But break is gonna break this loop. But it's still gonna repeat. That's kind of a trip because I wasn't sure if break was gonna break the whole loop or not. Like completely. But I guess it's only gonna break this function right here. But it's still gonna loop back around. That's a trip. So the only function, this is gonna break is the for loop. And that's the counting. Right? Or it's gonna break this loop right here where its count equals to 0. But it's not gonna break this. And this will keep looping. Oh, that is a trip. Hey, what's up? I'm getting like the coding stuff. It's so much. What is it? What? You want juice? Okay, I'll get you juice. I will get you juice. No, apple juice.
No, juice.
Why'd you take your pants off?
Maybe.
What do you mean, maybe? Olivia, here. You need pants on. Please. Do you want juice? If you want juice, you have to put these on. Okay. I got a baby. I'm a dad, so that's the thing. I wasn't quite expecting this outcome out of this one. Cause, well, the break, I understand how break works. It breaks a loop. But if the while loop continues, then I guess it just breaks the for loop. I don't know. It's kind of confusing. Well, no, because it's not that it breaks. It has to break the while loop technically, because the count equals 0. That's what doesn't make sense. Because if the while loop restarts, the count will always go back to 0, right? But if the for loop breaks, then it doesn't add anymore. So that's what's going. So okay, so at the 0 loop, the count that this loop doesn't go through. But why does count equal 1? It gets a +1 every time. Because I thought this +1 is only during this loop. Oh god, this is hurting my brain. Why would count only get a +1? Or plus or equal to 1? No, this plus equals. Because you're adding it. But I thought this count is part of the loop. I figured it out. Okay, so either way you're gonna go through the sequence. And you're gonna this loop's right. It's through all of this. And okay, so it is the for loop that breaks, because you're gonna go through the for loop once. It's gonna add 1 to count, because you're gonna see that it has a letter, and it doesn't loop back because if iteration is 2%, then it breaks right here. So it is the for loop that breaks, and it gets 1 because it only runs through it once. And then when this is an even number, then it's able to loop back until it runs out of letters, then it equals 12. That's why it equals 1, because it only runs through once and doesn't loop back. And it does break only the for loop, not the while loop. Okay. Okay, I got it. So, how many times will it print the 5 times? What is the largest variable iteration that will be printed out for? And what is the smallest value that the counts will be printed? Apparently 1. Per doodles. Alright. Let's see. Approximate solutions. I don't even know how far I am in this thing. Like, how do you find out? Like, I don't even know how long this stuff is. Finger exercise. So all the way to 12, and then midterm final. So what, I'm 10% through? Is that what it's saying? I don't know. Okay, well. Alright, here we go.
We've been using exhaustive algorithms, guess and check algorithms, to solve some simple numerical problems. But if you think about it, they've all been doing things with integers, where there is a finite number of choices that we have to check. And that makes sense. We certainly run.
This dude's got to be Canadian, because I noticed whenever he says about, he's kind of says it like almost a boot. And isn't that how they say it in Canada? But he's from MIT. That's like Minnesota or something. I think it's Minnesota. But he's got that like that's a Canadian thing, right? Like the boot.
Through all of them until I get to either the right answer or determine there isn't a possible answer. But now suppose we want to find, say, the square root or the cube root of any non-negative number. It could be an integer, it could be a float, it could be any number. I can't generate all possible guesses. They're infinite. So I can't, in this case, guarantee an exact answer, but I could come close. Now what I just want to do is try and find a guess that's close enough to the cube root or the square root of the thing I'm looking for. I can still use that notion of exhaustive enumeration, But I'm going to now have to pick examples where I take small steps in order to generate the guess and check to see if I'm close enough. Let's see what that might look like. Here the idea is I have to define what's a good enough solution. So I'm going to start with the guess, say 1. I'm going to check to see if that's close enough. If it isn't, I'm going to change it by a tiny amount, say 1.001. Check that one, and then 1.002, and keep doing that. So I need to increment by some small value as I go along. But I also have to define what does it mean to get close enough. It won't be exactly the same, because I'm not going to be able to guarantee that. So here I'm going to use, in the case of cube root, something that tells me whether I'm close enough. By looking at the guess cubed, take the absolute value in case it's negative, and look at the difference between that and cube to see if it's less than or equal to a small number. And if it is, I'm going to say I'm close enough, and I'm going to stop. One of the tricks here is that when I have these small values, I'm going to have to be careful. If I make them really small, I'll make sure I find a really good guess, but it's going to slow the program down. If I make them really large, I might actually miss the answer. And similarly, when I decide how close I want to get with epsilon, if I make epsilon big, I'm going to make it easier to find an answer, but I might get a less accurate answer. And so I have to think carefully about how I do both of those. But let's look at that idea to see how I can still use the idea of guess and check, but now with things that could compute the cube root of anything. So here's an example. I'm going to start off with some value for the thing I'm trying to find the cube of. 27 is going to be an easy one. I'm going to set up some initial values. Epsilon is going to be something that tells me how close I want to get to the answer. Guess is where I'm going to start. And increments the size in which I'm going to increase my guess as I move along. And just to keep track of it, I'm going to set up another variable called number of guesses. I'm going to use that to keep track of how many times do I go through the loop as I do this. And then what does this code do? It says, while the difference between the cube or the guess cubed and the thing I'm trying to find the cube root of, while that difference is still bigger than epsilon, I'm going to keep going by incrementing guess by increment. There's that plus equal that I've used before. And changing number of guesses by 1, saying I've done another guess and keep going. I'm going to keep doing that until I get to something where the difference between guess cubed and cube is small enough, and at that point I'm going to stop, and I'm going to return both how many guesses did I run and some information about did I find the right answer. Let's see what happens if I run that. So there's a piece of code. Let me start with 27, which is the thing I had before. And if I load that and run it, it gives me, not quite the answer I expected. It says 2.9970000001906 is close to the cube root of 27. And that's true. We're going to see in a little bit why it doesn't just give me 3. It gives me this funny answer in there. But you can also see that it took almost 30,000 times through the loop before it got to that.
God dang.
Why? Because I started with a very simple answer, 0. That wasn't close enough. Then I went to 0.0001, then 0.0002. And you can see I'm going to have to do a lot of things until I get to something that's going to give me a good guess. Now, I could pick another example. Let's make it 29, which I know is not a cube root. Let's see what happens if I do that. It's not a perfect cube, but in this case it found it. That's actually nice. In the previous case, I could only find things that were cube roots of integers. Now I've got something where the cube root isn't an integer, but I can still find it. This took almost 31,000 times through the loop. So I could say, you know what? I want to use something where I'm going to step a little more broadly. Let's step every 1,000th of a step rather than every 10,000th of a step. And now if I run it, okay, I get a little bit different guess, but it only took 3,000 trials through it. And if I change it to say the increment should be in hundredths, I can run that. And if I do that, oops, sorry, it decided it didn't like that. Let me think about why it didn't like that. What's happened here? It's off in an infinite loop. And the reason it's off in an infinite loop is because I'm checking only to see if I get to a place where it's close enough. I've actually gone right past the cube root and it's still running. So I need to stop this and I'm going to interrupt it to hold it back. That's something I need to fix. So if I go back to a little bit better increment here and rerun it, I get back to the thing I wanted to have. Okay, how would I fix that? I need to make sure that the guess isn't too big. If you think, and I'm going to go back to where I was. With this test, it simply says when guess cube minus cube, as long as it's bigger than epsilon, I'm going to keep going through the loop. If my step is too big, I could try something just below cube, but not have it work, and then go past cube and keep going further and further on. That says I need to make a change here, so I want to make sure that my guess is still small enough. And if I make that small change, which I'm going to do over here, and guess less than or equal to cube, I should be in a little bit better shape. I can still run the same one, but now if I change increment to tenths, run that, it gave me a solution. Not a very good one. It basically says I didn't find a solution, but at least I didn't keep running forever. What was the point of doing this? It's not to try and trick you. It's to remind you that as you make changes to the code, you need to think about the consequences. And this was one where my test wasn't capturing all of the cases. So what can I say about this particular algorithm? The step could be any small number. If it's too small, it's going to take a long time. But as we just saw, if it's too large and I'm not careful, it could skip over the answer without getting close enough. At least in this case, I stopped rather than running forever. In general, it's going to take x divided by step number of times through the code to find a solution. And so clearly, as I make steps smaller and smaller, it's going to increase the number of steps, and I'd like to find a more efficient way to solving this problem.
Yeah. The guessing sounds like a bad idea. Estimated time to complete 10 minutes. Consider the following code. X equals 25, epsilon 0.01, step 0.1, guess 0.0. Okay, while guess is less than or equal to x, 25, if absolute guess was that squared, take away x is less than epsilon break, else guess plus equals step. Guess is 0, so it's gonna count up from the 0.1 as long as it's less than epsilon, which is 0.01. Okay, so I guess is 0. While that's less than or equal to x, 25. Guess cubed. I'm at 0 right now. Take away 25. Negative 25 is less than this number. Break. Oh, because take away an x, if this is 0, it turns, and that's why they got absolute, because you run on the negative side of things. So here you hit the barrier of this when you start creeping onto the positive side. So you're on the negative side, you work your way down from 25 to find the square root of 25, and you run down the numbers on the negative side until it hits basically the positive side, and else guess is plus equals 2 step. rerun step is the one that's counting up. Okay. If absolute guess script is less than excuse me, print failed, else print succeeded. As long as it's now suppose we try the following. Alright, let's see what this one. Oh wait. Okay, I can't put it in because I gotta read what this does first. Alright, what's the difference between here? Okay, he changed this. So, if it's less than epsilon, break what? The if? Or the while? Else, guess plus equal step. Oh, that's like the same sequence, really, actually. Because if, all it's saying is if it's doing this, then do this. And it says if it's doing this, then break out of the loop. But if it doesn't equal this, then you're going to keep doing that, which is the exact same thing. It's just rewritten. The same thing. Okay. It should have the same outcome. The script successfully completes principles. I feel like it would do the exact same thing because there's nothing really changing here. Because all that's doing is, instead of making it in one situation, if it's less than or equal to, you just do the opposite. You're like, if it's, the other way, if this is less than this instead of the other way around, then break. Otherwise, you're going to keep doing that, which it's the opposite. It's going to be off by what, one number? Yeah. Yeah, it should still do the same thing, I'm pretty sure. Okay, and now suppose we try this. So what is the difference here? Okay, they changed it again here. If guess is less than or equal to x, guess plus equal step, else break. Okay. Alright. What this is gonna do, if guess is less than or equal to x, guess plus step, while a b, wait. Oh, they changed that top part too. Okay, hold on. While guess then is, they flipped those ones. Oh man, is that really gonna change anything? While guess is less than or equal to x. If epsilon guess is greater than or equal to epsilon. Oh man, this is a little tough. Not gonna lie. X equals 25. Is this different? Oh my god, it's like barely different, dude. I don't know. I mean, really, because, it's the same thing. Well, no, wait. Because the loop's kind of different, but it's still a loop. less than or equal to epsilon if guess is less than x. Guess step, else break. Oh, God dang, I wish I could. This is hard to. Hold on. I feel like it would do the same thing, but it can't possibly keep doing the same thing, right? I mean, that's not what they're trying to do. Oh, God dang, I'm going to run it. See what it does. It did. And this one is too, right? Man, that's going to mess with me. Ah, this one creates the infinite loop. Okay, so this one is fine, but I was wrong about this one. This one comes out an infinite loop. Why? Because if this is the case, then it puts it in an infinite loop because the while it's less than or equal to x. It doesn't have a break or an else. It doesn't have a way to exit the loop. Because like, that's the same. All they did was if that, then break. And they put if that, then guess plus equals two step. And this is else guess plus equals step. Well, yeah, you did. There's no way to stop it from going past. Okay, I messed up. So much brain work. Finally, let's use the same code as immediately above, but change the first line to x equals 23. Note that the square root of 23 is roughly 47958. Select the answer that best describes what occurs when the modified code is executed. What do I think? Hence, if any of the above answers confuse you, try running the code on your own machine and inserting print statements to print out intermediate values of variables so you can examine what happens to certain variables. Okay. This is what I'm thinking, right? Finally, let's not use the thing. Okay, so all you're going to do is this one is turn it to 23. But 23 doesn't really have that close of a square root. So because it's a further number away, what's going to end up happening? Well, it's not going to be 499. See, 23. If you're taking 23... Man, screw it. This is too much brain work. I'm just gonna type it in. Okay. This is hurting my brain. I could sit here and look at it and figure it out by looking at it, but this is so much easier just to try it. I don't have the patience. Okay. Let's see what it does. It just says failed. Crap. Now, why did it say failed? I figured it was going to say failed. They weren't doing that for nothing. The reason it failed is because if absolute guess, if the square root is less than x, and, okay, wait. If guess take away x is greater or equal to epsilon, print failed because it passed it. Because I think what it is like maybe if we had put an extra 0 and then print Yeah, that's what it is. It's because you can't find a close enough number within the infinite guesses of this. Oh, I can't delete it. So that's all it is. It's because 25 you can find a closest square root, but since 23 is a more decimal arranged number, that it's going to change it to where you need to make more guesses. By like a tenth. And that's the reason that it fails. Is because it doesn't, that sequence doesn't give it to the 10th power of every guess. Way more guesses. Okay. Welcome back. For my hoodie.
For
It's
your
my
hoodie. It is your hoodie.
Oh.
It's like, I like your hoodie, Attack on Titans. I was like, fuck
Yeah. I know, I got the Attack on Titan symbol on the car too.
he was like, I almost watched all of it, but then I got really into One Piece. And he's like, I had pulled back because I was watching too much One Piece. And I was just like, man, you have to finish watching.
Yeah.
You stopped recording?
No, I just put restroom break on there.
Oh.
Because I gotta go to the restroom.
So it's still recording?
Yes.
Oh.
I mean, you can turn the mic off if you want. I
No,
guess.
that's fine.
But I
It
gotta
doesn't
poop.
Go poop. I still talk to you.
Yeah, you can still talk to me.
But yeah, so it was just like, bro, you have to finish watching Attack on Titans. He was like, it was really good. I was like, it gets better. I was like, I can't even explain the end because like I just can't. It's just, it's like, it's good. It's like it makes you happy, but it makes you so mad. But you can't be mad at it because they ended it so well. But it's just like I can't explain it. And he was like, oh, I have to watch it.
One Piece is good because it's just like so oddly like you know how like in shows and animes that like and everything there's like rules to the show, you know?
Yeah.
One Piece is like it doesn't really have rules, so they can kind of do whatever they want, but at the same time they over explain stuff to make it feel like it has rules.
It's filler. Well, I feel One Piece has a lot of filler episodes.
No.
And if anyone wants to argue with me, they can fight me.
It doesn't.
You're like, no.
No, you're wrong.
I am not wrong.
No, you're actually wrong.
I am not wrong.
No, you're.
You want to fight me? Do it on camera.
It doesn't have filler episodes.
Feels like it has filler episodes.
Why? Because it's got so many episodes.
It just feels like they're repetitive. It's filler episodes.
It literally, Naruto has more filler episodes than One Piece.
And I don't watch Naruto. I'll watch One Piece though.
Well.
I'm gonna start my compost pile today. Yay! Finish these piles of clothes. I have no idea where I'm gonna put them. Our closet is not as big as it looks once you start putting clothes inside of it. Hi, Milton. How are y'all doing today?
I drank a coffee, but.
Drank a coffee. Did it catch up to you?
Yeah, but some stuff. All it did was make me poop. It didn't wake me up.
Yeah, it's because you mixed it.
Cause I what?
You mixed the things with the thing.
That's the things.
Yeah. Last night. Yeah, you mixed it. When you mix it, it makes a difference. Yep. No. Wine and beer.
But coffee always makes me poop.
I'm not talking about coffee.
That's what I'm saying.
Oh my
I
gosh.
drank coffee and it made me poop, but I didn't wake me up.
So I have the curtains for our room, the blackout curtains. The only thing is we need curtain rods.
10-4.
So I'm probably gonna get some here in the near future. After I refix those boxes. How's your coding stuff coming along?
I mean, trying to learn it. I'm on a deadline now, so I'm trying to do something. I better figure something out. I only got a few months.
Hey, you got a deadline.
Yeah,
Now you know.
Because right now we're relying on long-term disability to pay for the house. So I gotta
Yeah.
figure something out.
I'll go on my computer here in a little bit. Put out my resume. I found a couple of promising job opportunities. And since my studio is a tattoo studio on my own hours, I can literally do it whenever I want. Thinking escrow agent pays better than the other one.
Anything that pays.
Until I finish my schooling.
Yeah. Right now we're kind of at the point where we need to survive. Not really.
I mean, I could get a job at the bar up the street. That's easy. I've got previous bar experience. I still know a couple of the bar owners I used to work for. I mean, granted, it was like a decade ago, but
Yeah.
I know how to pour a good beer. I can pour up some shots and make Long Island iced teas and...
I mean, I've never known people to work at bars to make money.
I've known people to work at bars that make money, but I hate to sound sexist, most of them were women. You can make good money at a bar as long as you're not drinking it away.
The only person I knew that worked at a bar was Junior, and he was always broke. He's the one that, like, every girl he got with took care of him.
Well, he also probably spent money on dumb shit.
I have no idea. He's always broke. That's all I know. He moved in with Mike and Ben, and he like within the first few months of them having the place, he lost his job and wasn't making enough to pay for it. And he got the biggest room, and then he kept the biggest room because he already had it. And then he wasn't even paying the bills.
Wow, nobody said anything?
I don't know. I mean, him and Mike got in fights, but
Yeah, no. His
like
ass would have
physical
got
fights, from what I heard. But
Yeah, his ass would have got kicked out.
yeah.
I did that with Kenneth. Kenneth was making the most money, so he got the bigger room. And then all of a sudden, like, he lost his job and was going through some shit. I was like, look, dude, you know, I'm not trying to kick you out, but you're going to have to do one of two things. You're going to either have to give up the room, or you're going to have to, like, you know, figure out something else because you're not paying your bills at all. And he was like, I do so much in this house. I was like, you don't do shit. I was like, we make food and everything. You don't wash your dishes, nothing. You'll leave your... He's like, well, I don't eat that much. I'm like, well, that's not our problem.
Well.
The bills is our problem. And he was doing things that could have gotten us all in trouble.
Bartender's a fun job. I always wanted to try to do it, but
Well, my friend Kate made that her career for the longest. Now she still bartends, but she's sober, so she doesn't drink because, like, the alcohol is what gets you. That's where you lose your money, is when you bartend and you start drinking. If you can't maintain, then you start not being able to keep up to the task. You start socializing. People want to tip you less. Like, it's just When you're sober in bartending, then you can stay on point and you don't lose your money.
Yeah. I mean, I haven't known anybody that's been able to do that, but
I know 2 people.
yeah. It's like pizza delivery drivers. Like I knew pizza delivery drivers that never made money delivering pizza. Really, they were able to keep their car going, and they had to, needed help with places to stay. But I don't know, just those kinds of jobs. I don't know.
Well, Cake owns a house, and
But that's
aside from making jewelry and
stuff that's tip based.
she does that for a living. Well, that and makes really awesome jewelry. She'll go. I think she makes more money making her jewelry now. She goes on tour and stuff with that. That's why they say invest in your dream. Oh, that's where I'm messing up. Okay.
Well, I need a job that's like full time, guaranteed hours, and either an hourly pay rate or a salary.
Me or you?
I mean, people, in order to survive, tip based jobs aren't.
Okay, well, I'm saying
I don't
if you
know.
want me to get a job right now, I know for a fact I could get a bartending job right now. But I put my resume in for other things.
I mean, I don't care. You can do whatever you want. I mean, either way.
I know I can do whatever I want. I've been doing it my whole life.
Yeah. I know. That's why I'm like.
So far, so good. I ain't complaining.
Well, I don't have a long term disability for the past 2 years, but.
You know. Excuse me.
We've been using exhaustive algorithms, guess and check algorithms. When we got integers, we saw that's nice because there's only going to be a finite number of solutions, but we won't be able to find, say, square roots or cube roots of numbers where that isn't a perfect square or perfect cube. We've generalized that to look at something that does a different kind of guess and check, where we take incremental steps, still enumerating all the possibilities within the resolution of that step, trying to find a solution. And we saw that that either means we take very small steps and we take a long time, or if we take larger steps, we might miss the solution. And I suggested we want to find a more effective way of doing that. So here's an example of that, and a wonderful tool that we're going to see a lot as we go through the course. It's called bisection search. Let's think about square root. One of the things we know about the square root of a number is that it lies between 1 and that number, if that number is bigger than or equal to 1. We'll do fractions in a second. So, square root of 25 lies somewhere we know between 1 and 25. Here's the basic idea. Rather than trying everything starting at 1 and taking small steps, suppose we pick a number in the middle, between 1 and say 25, 12 and a half. If we're lucky, that's going to be close enough. Now, it's probably not close enough in this case. We know where it is, but it's a nice start. But we can take that idea and generalize it. If it's not close enough, then we can ask, well, was the guess too big or too small? And in particular, if that guess g squared is bigger than x, we know it's too big. So what can we say? Well, we know that the answer has to lie below g. And that's really cool, because it says all of this stuff here, throw it away. I don't have to look there. I know that the answer has to be somewhere between 1 and g. Do the same thing. Pick something halfway between. That's my new guess. Try it again. If it's close enough, I'm done. If it's not, ask the same question. And for example, in this case, if g squared is less than x, then we know it's too small. So we can throw that stuff away and only focus on this portion. And again, pick something in the middle and keep trying. You can already see why this is going to be really nice, because on each step, I'm throwing away half of the things that I don't have to look at anymore. And that's going to let me hopefully very quickly zero in on finding the right solution. That's a wonderful idea. It's called bisection search, and we're going to use it. So, what did we say? At each stage, I'm losing half the values. Really cool. Let's see what happens if we wanted to actually make code for it. So this is a little bit of a busy slide, but we'll walk through it. This is an example of computing square root using that example of bisection search. I'm going to start off just giving it the thing I'm going to look for. X will be 25. That's the thing I'm going to use as the root. Again, I'm going to pick something that I'm going to use to tell how close I am. And I'm also going to keep track of how often do I actually run through the loop, just to compare it to what we saw earlier. I need to set a low value and a high value, the range in which I'm going to look. Initially, that is 1 to the to the number itself. And then I'm going to make an initial guess, just halfway in between. Just high plus low divided by 2. And then I run through one of those nice little loops. What do? I say, if the difference between the answer squared and x is bigger than or equal to epsilon, I'm not close enough. And in that case, I'm going to print out some information, increase the number of guesses by 1, and then do what I just did, which is if answer is too small, that is, if answer squared is less than x, then I can change the low part of the range to move up to answer. And if answer is too big, I can change the high part of the range down to answer. As I did before, I start out here. If answer was too big, I change the high range to bring it down into there. If answer is too small, I bring the low range down into there. And I keep sorting it down until I get into something that's...
Hold on. So while it's less than the limit you're giving it to guess between, print low, press string low, not low one, plus high, oh, you're having it print out a code low equals, okay, low equals 1. Oh, answer equals high plus low divided by 2. God dang. Okay. High plus string high is x. X is the number. Answer equals string answer. Answer equals high plus low divided by 2.
I did before. I start out here. If answer was too big, I change the high range to bring it down into there. If answer is too small, I bring the low range down into there. And I keep sorting it down until I get into something that's reasonable. This algorithm just captured that idea I just described.
Thanks.
So let's try it out. We'll do it with 25. Here's a bisection search on square root. And if I run this code, Wow.
13.
It actually got there very quickly. It did it in 13 guesses. I'll remind you, in the previous case, we took 30,000 guesses to get there. I don't want to print all that out on my screen. And notice how quickly it zeroes in. It starts off with low 0 and high 25. And then it says low 0 and high 12.5. And then low 0 and high 6.5. You can see if you look at the printout how quickly it narrows in on the range. That's really cool. Okay? Do the same thing with cube root. I can do exactly the same idea. This is almost exactly the same code. The only difference is I'm using guess cubed rather than guess squared. And I'm going to keep track of otherwise exactly the same information. And let's compare that. If I go over and pull up my cube root example, we'll start with 27. Again, I'll remind you that in this case I was doing 30,000 checks to deal with this. Now I run it, and in 14 guesses, it gives me a really good answer. And if I pick something that's not a perfect cube, like 54, and I do the same thing, in this case it took 15 guesses to get me a really good answer. This is a powerful tool. That idea of bisection search, throwing away half the possible values at every stage, lets me very quickly zero in.
Okay, because you equal your, okay, low equals guess. Okay, guess is high plus low divided by 2. Well, low is 1, high is cube, 27, so you start off with 27 and 1. And that plus that divided by 2. Well, absolutely, this is, so while it's not the right answer, if guess is less than cube, low equals guess, high equals guess.
As before, I can ask, well, can I do everything? This is only going to work for numbers bigger than 1. What about
Well,
fractions?
I don't
know
have
with
time to
fractions
play
between
Roblox.
0
I
and
gotta
1
zone in
now,
on this stuff.
the
Sorry.
difference is that the root doesn't lie between the number and x itself, it lies between 0 and that number. But that's an easy ways to change, and we could actually think about making that change. But just to remind you of how powerful this is, notice what happens. If I start out with the number n, on the first guess, I reduce the set of things in half. On the second guess, I reduce it by another half, so it's now n over 4. After g guesses, I've got a range that's only n over 2 to the g. And what this says is that in an amount of time that bit is going to grow as the log of n, I'm going to get to an answer. That's really nice because it says I don't take linear time, I actually take less than linear time to get there. We'll come back to that idea later on in the course, but this is a great example of a logarithmic time algorithm finding an answer very quickly. I jumped ahead a little bit because I already started talking about what happens if I want to look for cubes only greater than 1. I could modify it to look at negative cubes, and I could modify it to look at things where the answer is less than 1. And so, for example, if x is less than 1, I just change the search space. So now, rather than going from 1 up to x, it goes from 0 to x. Rather than going from 0 to x, I want to go from x up to 1. I'm not going to do it. I'm going to leave it for something you to try out, but it's really easy to make that change. And again, notice what I've done. Start with the basic set of code, check to see what it runs on, and then decide if I wanted to use the same code, how could small changes have it run on other kinds of solutions. What can I take away from this? Bisection search really radically reduces computation time. I went from 30,000 times through a loop to 10 or 15 times through a loop. That's really nice. And this should work on any problem with what we would call an ordering property. That is, the value of the function being solved varies monotonically. That is, it increases as the input value increases. G squared has that property. As I change g, it grows. G squared grows as g grows. G cubed, same kind of idea. So bisection search will work on any problem that has that kind of property. We're going to see more examples of that as we go through the course.
creates an infinite loop. Oh. I mean, it didn't crash it, so I guess that's it. If you're comfortable with installing. I think I'm good. I didn't have nothing like that happen. Alright. Okay. Alright, man. Play some Roblox if you want. It's no worries. I gotta do this, so. You'll create a program that guesses a secret number. The program works as follows. You, the user, thinks of an integer between 0 and 100, not inclusive. The computer makes guesses, and you give its input. Is its guess is too hard, too low? Use Okay, so 50. C directly low. Well, so it halves it every time until it gets it. Okay. Endpoints. Your program should use basic. Notice if we have two print statements high there, the output will have each string separate line. Yeah. Now try adding the following. And equals. Oh, that's weird. Test cases to test your code. Okay. Okay. So I gotta make a code for this. Okay. All right. it's gonna start with 50 every time. Oh wait, this one's different. Oh. Number 50. Okay. Inputs. If age. Oh, let's read about that. If input equals age. X. God dang it, how did it? Let's stay within 100. Okay, so let's do this. How about we put in like a high and low, right? H equals L equals how's he's having it. That's right. He's having the guess. So if input is H, then X is, what am I trying to do? Plus H divided by 2, right? So H, if at 50 is, so it'd be 50 plus 50 and then 100. No, that wouldn't be right, because look, divided by 2. Let's see. Divided by 2. No, because that'd be right back to 50. God dang it. I'm messing this up. Hold on. While input does not, no wait, that's not it. While input does not equal C, then you're gonna do, then we do the, I keep forgetting about the double. Okay, if input equals H, what's X? That's 150 divided by 2. That's 75. Okay, that probably works. And then you know what? I wonder if I can put this here. No, I think I gotta put it after. God dang it. Do I? Hold on, let me. While input does not equal C, right? So let me see. Break is outside of loop. doing wrong. I remember the wild thing. But if it is C, it's not. Okay, X. X. Okay. I don't. God dang it! Why am I got it stuck in this loop? Do this. God dang it! God dang it! I don't know what I'm doing wrong. Okay. This one. Sorry, I did not understand your input. LF input is equal to L. About syntax. Dang it, I messed something up. Oh, G. Oh, crap. If equal to low, then wait. If it's too high, oh, I did that the opposite. That's if it's too low. Hold on. If it's too high. Okay. Yeah, this is too low. Okay. It's too low. Okay, and if it's too high, I need to go the opposite way. So x equals. Take my guess. I'll probably add it to. Okay.
on, baby.
Oh, okay, hold on. Okay. Okay. Dang it. Dang it. That's not working there because now I got stuck on. I'm struggling right now. It is too high. 50. Take away 50 equals 0. Why is this so hard for me? Jesus. That's not right. Okay, if I start with 50, and I'm trying to get to the halfway mark. Okay. Alright, let's try it. And then okay. Okay, that kind of works, but not exact because it turns it into a freaking decimal. Oh, dang it! Why'd I turn it into a decimal? God dang it! Because I'm dividing. Okay, let's see. If I'm let's say my number is 27. 27, so let's say it's too high. Oh man, my idea didn't work at all. God dang it. 75. Is there a way to round? Okay, let's try this. x equals 0. If it's too high, I need to get to 75. What am I doing wrong? God dang it. Oh, math is not mathing. I need to add it by half of that. But then if I do that and it turns into a freaking decimal, it's too high. X take away X. But if I put division, it turns everything into a goddamn decimal. Yeah, this ain't working because it's freaking. Dang it. I just don't got the freaking math right, dude. Like, oh my god. Dang it. Why am I not doing this? God dang it. Oh my god. doing this right, and I don't want to look it up. I want to be able to figure this stuff out myself. God dang it. Why is this so complicating to me? This should be simple, dude. This is simple stuff. I don't know why this is... I can't figure out a way to freaking do this. This is... Okay, it's gonna be that. Take away 100. God dang.
Shut up, Pepper.
It doesn't work. It doesn't work. I don't know. I'm not doing this right at all. Well, math is not just like I can't. Okay, think about it. It's come over 50. God dang. I need to use a different digit or something. Like, that's my problem. Equals. Okay, so it's not 15. I need to make a change too. Because A can't stay 25. But it says X equals X take away A. this is half of x. It should be x take away x divided by 2, honestly. God dang, why is this? I know how to find the average of something. You add it together and you divide it by 2. You can't divide these by 2. X 50 take away 100 is 50 divided by 2 is 25. 50 plus 100 is 150, 75. Let's see, but then if I do that, it goes to 87.5 instead of 87. How do I keep it? -6. Well, I need to do something different. It's not this whole thing divided by 2. I gotta do something like where the number that's subtracting from x. What I do this time? Oh, 50 take away 50, 0. Okay. If it's too high, then subtract. If it's too low,